maybe the most maligned and hated question you could ask a team member in software development is, when will it be done? And I say this tongue in cheek, but also kind of seriously, because essentially what we're being asked is to predict the unknowable future. So it creates this visceral reaction in a lot of us, because not only do we end up spending a lot of time that feels wasteful upfront doing planning, but our estimates are wrong, and usually very wrong. And yet we're often still held to those estimates in the form of deadlines. And then it becomes the burden of the frontline team members to determine what corners to cut or how many hours overtime to work to meet those deadlines. But it's also just as frustrating on the other side of this. And I can say from experience, in my 23 plus years doing this, I've been a delivery manager and a project manager. And I've been on the other side where I'm trying to meet the needs of the organization, that to be predictable, to have some sort of plan together, and to not be able to do it. And the more I try, the more control I try to exert, the more planning I try to do, actually, the less predictable it becomes, the more frustration I create, etc. This is the paradox of predictability, where the more predictable you try to become, actually, the less predictable you end up becoming. So is there any escape out of this paradox other than just like going into landscaping or something? And yes, I do think that there is a way out. And especially if you're a leader or a manager or a planner of some sort, or product manager, this falls very much in the sphere of your influence. And even if you're not one of those roles, I think it's important for all team members to kind of understand this idea of predictability, how to avoid some of the traps, and so that we can develop the better language that's not so adversarial between team members and the planners in the organization. So this whole idea of a paradox is kind of hard to wrap your brain around anyway. By its very nature, it's not intuitive. So I'll tell you a quick story, and then I got a couple of other examples here that you may be able to find more relatable. About 12 years ago, we had a house built. And one of the things that they offered was a 4-month guarantee of the build. So from between the time that they broke ground and the time that they handed you the keys, they claimed to be able to do that in 4 months. So of course, during the build, like, unexpected things happened that there was no way they could have planned for. The biggest thing is when they started digging the basement, they found that the water table was a lot higher than they were expecting, partially because we had like record rainfall in that March. So that ended up setting the project back weeks. You can kind of see where I'm going with this. So I started to observe corners being cut, and there were things that happened. There were so many issues that started happening. Like, one was a guy was rushing and he smacked into our foundation with his front loader and like cracked the foundation. There was another incident where we had a fireplace built. I came into the room to check things out, and I could see the hearth was like 2 feet to the left, out of center from the fireplace. And all you had to do was just glance at it and you could tell. So they called it done after 4 months. And yet for 3 years, we had them out here fixing things that were, in my opinion, were completely unacceptable and were a direct result of them rushing to try to meet the date. So the paradox here is that the more they planned, the more rigid they tried to be, and the more strictly predictable they tried to become, the less predictable it became because of the rushing and the plan itself not having enough room to be flexible to adapt to things that happen. Sound familiar? So some other well-known examples of a paradox. One is called the Cobra effect, and you may have heard this before, but they had a real problem with cobras, I guess, at one point. And so they created this bounty where you get paid $5 or whatever to kill these snakes. And well, what happened was people started creating cobra farms, and so these bounty hunters would just go buy the cobras from the farmers and then turn them in for cash. And so they had this whole racket going. And when they caught wind of this, they killed the program, and then the cobra population just skyrocketed. So they ended up creating more cobras by trying to control the cobra population and reduce it. They ended up increasing it. The last example I'll give, which is really interesting, it's called Brace's paradox. And it's related to traffic. And it's this idea that if you have a lot of congestion in a city, you add more lanes to your highways, you expand the capacity of your traffic, then you can reduce congestion. But what actually happens often in practice is when you increase available capacity, people change their driving behaviors, and then everybody kind of flocks to this new thoroughfare, and you end up creating more congestion. So adding more lanes can create more congestion. And so it's, like I said, it's this hard to wrap your brain around thing. Okay, so 5 minutes into the video, let's finally actually bring this back to software development. So real quickly, what do we mean by predictability in software development? And it's really kind of one of three ways that I've seen. One is throughput, essentially. So it's just like the number of items that we're, shipping across the assembly line. So usually it's either user story count or story points. So the throughput, we're trying to make that predictable. The other is the scope itself. So we might have like a number of features that we're saying we want to make sure, like, how long is this one feature going to take? The third one is what outcomes do we want to achieve? So we're trying to, increase customer conversions or whatever. So unfortunately, I haven't seen the third one very often in practice. It's usually the first one. It's usually throughput itself. So how is it actually done in practice? Well, it's you've all probably experienced it before. In order for us to be able to predict how many story points we're going to be able to deliver this quarter, we need to do a lot of upfront planning, because the bane of predictability is surprises. So we do the upfront planning to try to discover as many of these surprises up front, so that then the process of development can be predictable, because anything unexpected happening is going to reduce your predictability. So, we'll just do all this planning up front. We'll do the mine sweeping, so to speak, find where all the landmines are before we start the work. That way, when we do start the work, we know that piece can be predictable. So that's detailed acceptance criteria. Usually it's mock-ups, designs of some sort. It's an architecture. It's maybe data models or different like design flows, test plans. So we do all this work up front so that the coding piece can be predictable. So that's kind of how predictability works and what it actually means when people think about it. But there are issues with this approach. And what often happens is when we try to make the software development process, the coding part, predictable, and we set more rigid plans and estimates and deadlines, as I mentioned, the team members will start cutting corners. They won't do that little bit of refactoring that would make the code base better, but isn't necessarily part of that one user story. So over time, tech debt accumulates because the team is being incentivized to ship story points, and they're being disincentivized to do anything that's outside of that number of points or number of features or whatever the unit is of predictability. So then what happens as a tech debt accumulates, this is in systems thinking, this is what's called a positive feedback loop. Not positive meaning like it's a good thing, but meaning that the more of something you get, the more of that thing you continue to get. And tech debt is the same way. The more tech debt you accumulate, the more tech debt you accumulate, because it starts to take longer to make changes, and it starts to become less predictable because there's more surprises. You go in there to make a change and you're like, oh crap, I didn't realize like there was all this spaghetti mess in here I have to deal with. So you start rushing and you add to the tech debt just to get that story done, because again, you're being incentivized to be predictable, not to deliver quality, not to increase the overall changeability of the system. And so this is really the main way, this is where this paradox exists, that the more predictable you try to become, it usually results in the accumulation of tech debt, which makes you actually less predictable. There's a few other ways too that this paradox exhibits itself. And one I've already mentioned is when these plans are formed up front and you organize all these teams and these large groups of people and you have all these plans, and if they become rigid, they become more expensive to change the plan. So then the goal becomes following the plan and avoiding change, and you get these things like change requests that happen. That rigidity in the plan reduces the team's ability to pivot or to adapt to things that are unexpected. It's like if you're trying to navigate through a swamp with a cruise ship, and you're being asked, well, tell me how long it's going to take. I mean, you don't really know, right? Because you might be able to get lucky, but there's a chance that you can get 3/4 of the way through the swamp and literally have to turn around and find a whole new route because the ship is just too big and unwieldy, Whereas if you had an airboat, you could look at a map, right, and just see, well, how many miles it is, and you're pretty confident that you can encounter whatever obstacles you encounter, you'll be able to deal with, and it's not going to impact the overall outcome. Another more subtle way that optimizing for predictability can actually decrease predictability is how the team members themselves are incentivized. And what I've seen in these heavy predictability optimized environments is that it's really individualistic, because, if success fail for a team is, well, we forecast 20 points and we meet 20 points, I have a story that's assigned to me. I'm going to meet that. It's 5 points. I'm going to deliver that 5 points because I'm going to do my part to make sure the team meets that goal. So I'm not going to necessarily take my time, out of my day. Now I probably would, and you probably would, but it disincentivizes helping each other. It creates knowledge silos. So when you're encouraging individualism, now I might just have my core area and I'm trying to actually get this thing done as soon as possible. So we're not going to do a lot of pairing within the team to share knowledge, because it's really about shipping the points. So we create these knowledge silos, which then reduces the overall team's domain knowledge, which then reduces our predictability, because, different pieces of work. What if I go on vacation? Well, now I don't know if this piece of work has to go to a different developer, we don't really know how long it's going to take because they've never done it before. And there's so many other things that this could be a whole separate video. The breakdowns in communication, the inequality that it creates on the team. It can lead to resentment and just like an overall lack of focus on the team goal, where I'm just focused on my user story versus the overall goal of the product itself. And that leads me into this other way that all of that kind of creates this culture, right? This factory culture where everyone's in it for themselves. We're not really connected to the outcomes at all, we as the team members, and our value to the organization is seen as just moving the parts across the assembly line. So that'll drive good people out of the organization, which then also reduces the domain knowledge. And this type of brain drain really destroys predictability as well, because one of the ways to actually enhance predictability is to grow the team's overall domain knowledge, because the more they grow their knowledge, when they get work, they've seen that type of work before. They know where that feature needs to fit in. They know where the bodies are buried, so to speak. We can more accurately forecast how long something's going to take, the more domain knowledge that the team has. So what is the way out of this paradox? Like, what is the solution? So another somewhat personal story. For a good chunk of my adult life, I would say suffered from extreme fatigue and some levels of depression off and on throughout the years. And I went to so many different types of doctors. And I went to one doctor in particular, and they ran a bunch of tests. And they said, well, you're suffering from adrenal fatigue. So they started giving me these supplements that would increase the function of my adrenal glands. The fatigue didn't actually get better, but I started to have other symptoms. And so I went back to the doctor and they upped my dose, because they said, well, you're just, we don't see what we're wanting to see in your adrenals. And I just continued to get worse. So I went to a different doctor, and after she ran some tests, she was almost horrified that my system was so out of whack. All these different hormones that are in your body that are usually in this delicate balance, mine were so out of whack, and they thought that I had some much more serious health issue. When I told her about my history, then that's when the light bulb went off, and she said, yeah, they were screwing with your system by just focusing on this one thing, this one hormone, and trying to give you supplements. They screwed up the whole system. She got me back on track, and I started to have a lot less fatigue and a lot of other downstream positive effects from her treatment. So long story short, maybe you see where I'm going with this, is the fix for this paradox is systems thinking. And I've alluded to this in past videos where we don't really have enough leaders and planners who get systems thinking. So the story that I shared, the issue was that other doctor fell into the sub-optimization trap. And that's what is referred to in systems thinking, where basically you go into one part of a complex system and you start turning dials in that part, and you might see positive effects, just in that one subsystem. But overall, the system, you've created suboptimal conditions, because in a complex system, you press a button over here, you don't always know what's going to happen over there, what the outcome's going to be. So you treat complex systems differently. You enhance them differently. So there's actually been a lot of research that's done about this and been published. One of them is The Fifth Discipline by Peter Senge. And he talks about how tweaking individual parts without understanding the whole system leads to, quote, today's problems coming from yesterday's solutions. And there's a good quote from this book: systems thinking is a discipline for seeing wholes, WHOLES. It is a framework for seeing interrelationships rather than things, for seeing patterns of change rather than static snapshots. And the last one here, many of you probably have heard of and even read, is called The Goal by Eli Goldratt, where he talks a lot about bottlenecks, where you create efficiencies in the system that aren't the bottleneck. You can actually make the whole system less efficient. It's this idea of the theory of constraints, where an overall system's performance is limited by its most constraining factor. So I would love to hear what you have to say about this in the comments. Like, in software development, like, what are the most constraining factors? One of the things I've always said is, if I go from typing 50 words a minute to 100 words a minute, it doesn't mean that I'm going to be able to double my effectiveness of a software engineer. So typing speed is not the main constraint in software development. So in systems thinking, we still do try to make changes, but basically we look for the bottlenecks first. We try to enhance and expand those bottlenecks. And then if we do make changes to one part of a system, we're still sort of monitoring the system as a whole. We're not just looking at just the function of the adrenal gland, so to speak. So then the last thing in systems thinking that I think it's important for especially leaders and planners to understand is this concept of feedback loops. And so there are positive feedback loops and there are negative feedback loops. The positive feedback loops are, as I mentioned with tech debt, where a thing begets more of the thing. So the more tech debt that gets created, they can start to grow exponentially, because then that leads to more tech debt getting created. More of a virtuous cycle that teams can get into is with continuous learning and improvement, because there's like this snowball or this flywheel effect that happens. That the more the team learns and they start to make little improvements here and there, and it tweaks, but then the flywheel starts to spin, and you can see exponential growth in a team's capability by investing in the learning and the improvement itself. A negative feedback loop is basically a feedback loop that has the intent of maintaining stasis, whereas a positive feedback loop is meant to kind of break out of stasis. An example of a negative feedback loop in real life is like a thermostat, where you want to maintain the temperature at a certain level. An example of a negative feedback loop in software development is, I mentioned Scrum, and it's not just Scrum, but when you have iterations and frequent inspection points, it's kind of like a thermostat. The thermostat is checking the temperature every so often, and if it needs to go up or down, then it cranks on the heat or cranks on the air conditioner. Otherwise, it just stays static. And it's the same way with our agile iterative processes, where we're inspecting the progress, how things are going, and making adjustments up or down, accordingly. And that's how we stay productive, and that's how we make sure that we stay aligned to the actual goals. So to summarize this, because it's been a little bit all over the place, predictability is not something to optimize itself. Predictability is a second order consequence of other things that you do in the system, like increasing domain knowledge, reducing individualism and having a cohesive team, aggressively tackling tech debt so it doesn't get into this vicious positive feedback loop, focusing on simplicity and changeability in the code and the architecture itself. And there's lots of other ways that you do these things, and over time, it enhances predictability. It's not as simple as being able to just plan everything out in advance and think that that's enough for you to gaze into the future accurately. So if you're still here, you are a real trooper for sticking through this sort of all over the place video. Leave me some comments. Let me know if you have any, ways that you might explain this differently, or you've experienced this, or ways that you think you can break out of this paradox. So anyway, I appreciate you. Thanks a lot.